So this is the key to Quiz 12. So this is the part we usually would do in class together. So number 1, you have the square root of 2x plus 5 minus an x equals 1. So your first step when solving radical equations is always to try and isolate the radical. If you have 2, you can't do that. You're stuck and you have to square both sides twice. But here we just have one radical, so we want to get it all by itself on one side and then square both sides. Remembering that the side with x plus 1 squared means I have to square the binomial and get x squared plus 2x plus 1. So squaring the square root undoes it. So we have 2x plus 5 equals x squared plus 2x plus 1. And then I need to get 0 on one side because it's quadratic. So if it was linear with just x's, I would get all the x's on one side and the numbers on the other. But it's quadratic, so I need to get 0 on one side. So I have 0 equals x squared minus 4. And that means x squared equals 4, so x equals plus or minus 2. So those are our two possibilities. But once you square both sides, you must test or check your answers to see if they work. So let's try -2, and you have to put them in the original equation because they're going to work in the quadratic. So you have to go back to the radical equation and see if they work. So 5 minus 4 is 1, square root of 1 is 1, plus 2 definitely does not equal 1. So x doesn't equal -2. That's not a solution. We created an extraneous solution by squaring both sides. So then let's test x equals 2. And we'll have 2 times 2 plus 5 in the square root minus 2. And we want to know, does that equal 1? I should have put a question mark here because I was writing a not true statement. So 5 plus 4 is 9. Square root of 9 is 3 minus 2 equals 1. So x equals 2 is the only solution to this equation. Okay, then the second problem is solving a rational inequality. So those have to be done in such a way that you check all the intervals. There is no other way to do it. So you want to find the zeros of the numerator and the zeros of the denominator because those are the dividers between true and false for this problem. Okay, so we have, let me copy the problem. We have 3 minus x quantity cubed times 2x plus 1 in the numerator over x cubed minus 1, and we want to know for what values of x is this less than or equal to 0. So non-positive, you could say. So first we're going to find zeros of the numerator. So we want to know when 3 minus x equals 0 and when 2x plus 1 equals 0. So that's going to give us x equals 3 and -1/2. And then we need to find zeros of the denominator because those are also places where we have vertical asymptotes and the sign, positive or negative, can switch on either side of a vertical asymptote. So those need to be on our number line as dividers also. So we need to know when x cubed minus 1 is 0. That what happens when x cubed is 1. And remembering with cube root, we only get one answer. So x equals 1. So our number line is divided into 3 pieces. Let me put it a little farther down. By these dividers, these zeros. So -1/2, 1, and 3, and make sure you put them in the proper relationship to each other on the number line or it will really mess up the whole solution. Okay, so we have 4 intervals. 1, 2, 3, 4 intervals. I always work from left to right. And then you have to do some kind of process that I can follow that's clear and organized. So I'm showing you a clear, organized way. You can use a different way as long as it's clear and organized. So my first interval is from -infinity to -1/2. And I pick a test point anywhere in the interval, and I find that people just do really good mental math with tens and ones and zeros, so I would pick -10. Then the other efficient thing about this is if I put 3 minus -10 cubed and 2 times -10 plus 1 over -10 cubed minus 1, all I want to know is about the sign of this, whether it's positive or negative. I don't care what number it is. So I make a little sign chart and I say 3 plus 10 cubed, that's going to be positive. -20 plus 1, that's going to be negative. And -1,000 minus 1, that's going to be negative. Just a negative number, sorry. So that gives me a positive result, which is not smaller than 0, so I do not want that piece of the number line. Okay, so now I'm going to look from -1/2 to 1. And I'm going to pick a test point of 0. Whenever 0 is in my interval, that's always my favorite choice. So I'm going to have 3 minus 0 cubed times 2 times 0 plus 1 over 0 cubed minus 1. And I want to know if that is less than or equal to 0. So again, I'm going to do a sign chart. And I have a positive number and a positive number over a negative number. So that is negative. So I want this piece of my number line. Okay, and then my next piece is from 1 to 3. So I'm going to pick 2. So I'll have 3 minus 2 cubed, 2 times 2 plus 1, and 2 cubed minus 1, and I want to know if that's negative. So again, I'm going to make my sign chart, and I'll have a positive and a positive over a positive, so that's definitely not negative. So I don't want this piece of the number line. And so my last interval to check is from 3 to infinity. And I'm going to pick 10 because it makes the math easy. So I'll have 3 minus 10 cubed, 2 times 10 plus 1 over 10 cubed minus 1, and I want to know if that's negative. So I have a negative number cubed, that's going to be a negative number. Then I have a positive number on the top and a positive number on the bottom, so this is indeed negative, and I want this piece of the number line. So now let me come back and look at the original inequality to see which things I include. So I include zeros of the numerator. So I want to include -1/2 because that was a 0 of the numerator. And I want to include 3 because that was a 0 of the numerator. And equality is included. But even though equality is included, you cannot include the x is 1 because that would give you a 0 in the denominator. So your interval notation is -1/2 to 1 with a square bracket on the -1/2, curved bracket on the 1, union, square bracket 3, comma infinity. So this is your interval notation, and this is your graph of the solution set. Make sure and ask if you have questions.